I've been asked to take a look at one of these. It's a switch mode power supply. It fills the frame. 40 amp. Always complaint being is that it doesn't work. But the initial complaint was that it's worked for about 10 minutes, then shut down. So the chances of finding a fault in this, slim to none. About 1%. Got all these components. If this was a power issue, as in bridge rectifier MOSFETs, I may be able to fix it. But this is probably going to be a signaling issue. It could be any one of these components is faulty. Let's turn it on and see what we get. I haven't checked any fuses or anything. See if it just goes bang. It's on. Power on the front. And nothing. Just check, see if it's getting the AC to the main spades. Let's test it. Nothing. That switch is on. Oh, now it's on. Okay, so it's getting AC into the board. Test for DC outputs. My probes are on the ends. There's some banana sockets on there. Switch on. Nothing on the meter, as you'd expect. Just knob for varying voltage, I suppose. Didn't do anything as expected. There's a green LED there, it's AC line, that never comes on. Even though I seem to have the VCC, the control voltage on the chip. That's it from behind. So it's this little board on there. Put that into the lights. That's as good as it's going to get. So this yellow wire, that's the ground wire from the chip, pin 7. So it's either this green wire or the yellow wire should provide the VCC. I'm going to plug this into 110 volts through the isolation transformer. See if I can take some measurements on there. I never usually wear gloves with anything, but I'm playing with higher voltages. So safety first. I've got my feet in a bucket of water, that's fine. Let's see if we get anything between yellow and let's go for orange first. So black onto yellow to ground. Try orange. Try not to rest my hand on the inside of the transformer. Nothing on the meter on the orange. Let's try the green one. Nothing on green either. So no VCC. Okay, no more pissing about. I'm going to take this damn thing apart, which means having to take a lot of the components, boards like this off as well, or desolder them. So I set my power supply on 2.4 volts, I think. It's a standard green LED, should be 2.4 volts. There's the light. does. I thought that LED would be bust. Measured the VCC on the 494 pin between there and secondary ground, and there's nothing there, no VCC. We'll have a look at the schematics and see if we can determine where it's coming from and why it's not getting there. 212 volts across that one. Let's see on this, the other one. 200 volts across there. Okay, so now I've got mains power. How about a quick look at the schematic from this? This is where my suspect lies, I think. That shows transformer 2. That's the beauty of doing some active voltage testing on this, because I can skip sections. See this line at the top coming into the transformer. That's the positive side of the main filter capacitors, which are 10 and 11. I know I've got positive there. Going through the transformer, and it goes through this little baby. I don't know what that is. I know what it looked like on the board, but it says looks like 1/2 TOP 222Y. It's a TO220 package, 3-legged IC. And the return path from the transformer goes through this one and to ground. So one from the transformer on one pin, one to the ground on the other pin. It looks like the centre pin comes from what looks like a feedback winding on the other side of the transformer. So it's either this not making it to ground, or it's not getting a signal. So what it actually looks like on the board, transformer 2, it's this little package here that can be seen, a 3-legged IC. Yes, this little bad boy. It's a TOP 222Y. I didn't know until last night what it was, but I hadn't done some internet research. It seems to be a pulse width modulating switch. It's an IC. It works both as a MOSFET and as an oscillator for this transformer that's supposed to be supplying VCC. Turn around a bit to get a slightly better view of it. TO220, that one. This is what it looks like on the board, this little triangular area here I've marked out. That's got a drain pin on the left, source pin in the middle, and the control pin on the right. Get that a little bit closer. Look a little bit closer. Okay, so drain, source, and control. Now when I power this up, so if this was passing current between drain and source, I should have 0 volts, but if it's switched off, that is no control signal here. I'll have potential voltage between these two. Let's see if I can measure it without shorting it out. The pins are a little bit close together. I'll probably use this one here, and that's the negative rail. So I've set the meter on DC voltage because I don't know what I'm going to obtain. So let's go negative capacitor to, which one's this one? Drains. That should show me a voltage. Yeah. Try to put my hand down so that can be seen. More, lower. Just about 114 volts. So that's between drain and source. They should be between source and source. So yeah, nothing there. 400 volts there. Does that mean he's conducting or not? Have a think. I'm satisfied that's not passing any current through this device. There's 222Y, because I've got voltage between, what was it, drain and source. If this was passing current, I would have had 0 volts. Just one thing left for me to do now is to check whether on the control pin on the right, whether that's getting a signal going to it. So it's either the device that's faulty or it's not getting a signal. Let's power that up again. This time I'm going to check between secondary ground, black negative, and the control pin. The meter's set on DC. I should be getting anywhere between 5 and 15 volts if this is working. Two volts. I can't see how it works, to be honest with you, because the primary side isn't energized. Got no idea how it's getting voltage on the secondary, on the feedback. I think the next step would be just to replace this IC, this 222Y, see if I can obtain one, and just do a direct replacement and see if that works. I've taken the IC out. Just show it for you. It's not focused or seen or anything, that's better. There's some numbers on there. What are they? GOP222Y. And they have some replacements. Let's go ahead and install that one. Now with that new IC installed, it's in there. I'm going to power this up directly from the mains through a series light bulb. See if there are any shorts present. Just making sure that none of these wires go back onto the board or short out anywhere. Contact. Pulsing. What does that mean? Sometimes they're short. What does that mean? Ah, I had the green LED down on there as well. That was on. Let's try that again. Green LED, so we've got VCC. Well, we didn't have before. What does that mean? And now same as previously, except I've hooked up the multimeter to the output leads. See if we get any reading. It works. Is it going to short when it's pulsing like that? There's only one way to find out, isn't it? Let's plug in without the light bulb, see what goes pop. And before I plug into the mains, I'll put a clamp meter across the AC input side. It's only gone up to 0.4 amps. But then again, the light bulb's limiting it, isn't it? Before I plug that into mains proper, I'm hooked up to my isolation transformer. You see the background there, 116 volts. That's protected by, I believe I've got a 1 amp fuse in there. So it's not going through the light bulb now. Let's see if that goes pop. Doesn't go pop. Oh, fantastic. So 110 volt in, 9.2 volts out. It's just not going to blow. No shorts. Excellent. Or excellent. This next step, the one I'm most wary of, is plug into mains, the house mains. Let's see. Contact. Still works. Shut the LED. There's a little knob that was on the front. Do something without being electrocuted. So we can vary the voltage. There you go. 9 out of 14 volts. Spot on, leave it on 12. I need to put a little load on this. Not much, seeing as it's disconnected from the fan and everything else. Let's find a 12 volt light bulb. Let's see if it'll power the light bulb. That bulb's only taking about 1.5 to 2 amps. It's a test. I'm not going to leave it on for long in case something gets warm underneath. It's been sitting on a piece of plastic. It's good enough for me for now. I can hopefully now safely put that back in its chassis. What a gigantic pain in the ass this is to put it back together. Especially things like screws holding the inductors and transformers with little plates on the end, and it's taken me about bloody hour and a half. However, having had my rant, before I go any further and seal everything up, I'll give it another small load test. I'll have to do the rest of this by candlelight. My main power supply in the corner's backed up. It's a day for power supplies. Okay. Let's turn this on and see if it goes boom. Hey, it still works. I think the voltmeter's showing us something. That's volts. And that's amps, just on about 2 amps. Green LED still working. That's fine. So now I can confidently finish this off. Thank God. that's it. Almost all back together. I need to check previous videos, make sure I got the case on the right way around. But apart from that, it's good to go. So what's my conclusion? Just one of these little beasts, TOP 222Y. It's the only difference between this and the scrap heap. And if that has been of any use or interest to anybody, feel free to buy me a kebab.